Okay, so the first thing that I have to do is cut down this melamine sheet. It is really big and it is taking up all of my workbench space. I probably wouldn't start with this normally, but since I need to clear my workbench off, I'll go ahead and just cut out all of the melamine sheet pieces, and then we'll get to building the frame that it sits on. And another problem is that I'm here by myself, and these things are really heavy. They're made out of like MDF or particle board, and then just coated with melamine. And so there's no way I'm going to get these by myself onto the table saw. I don't even have an outfeed table built yet, so that's going to be a problem. So I think what I'm going to do is just drop like 3 or 4 2x4s underneath this, and then just use a track saw guide, or not actually a track saw, but a guide for a circular saw, and just cut them that way. Not ideal, but it'll be fine for what we're doing. To raise and support the melamine sheets while I cut them, I placed a set of 2x4s underneath each sheet. This will make sure they don't crack or bend during cutting. I have this handy cutting guide for making straight cuts with a circular saw. Since the offset on my saw's guide is 1.5 inches, I need to subtract 1.5 inches from my measurements when using it. Now here's a pro tip for you. When you cut melamine board, melamine is just a really, really thin layer of material that's adhered to the top of some other material like plywood or MDF. And when the saw blade goes over it, especially if your saw blade is even the slightest bit dull, it will chip out the melamine and it'll leave this jagged edge all the way down. One of the ways you can help prevent that is masking tape. So just run a piece of masking tape all the way down your board, right on the cut line, and then rub it in real good. And then when you cut, the masking tape will help prevent the chip out. It's beautiful. The masking tape also has the added benefit of keeping the base plate of your circular saw from scratching your boards. But for all of this to work, it's important to make sure that the tape is well adhered. As I cut and stack components for projects, I also use masking tape to label each part. This is incredibly helpful days later when I inevitably can't remember what is what. If you've never used a circular saw guide before, it's amazing just how clean of cuts you can get. And when working alone with big sheets, it's a lifesaver. I'll leave a link in the description where you can get this one. A few minutes later, and I have a stack of parts ready to become my work surfaces. With the tops finished, it's time to move on to making the legs. I am making this bench slightly taller than standard cabinet height as I want it to be comfortable to work at while standing or sitting on a tall lab stool. The legs are just sanded 4x4 posts that you can get at any hardware store. I cut 6 of them, 4 for the main table and 2 for the side table. I'm going to put levelers on the bottom, so I used a speed square to find the center of each post. I then used a punch to make a starting hole in that center location, and then I drilled down 2 inches deep. Each leg will get an insert nut. These nuts will self-thread and are driven in with just a standard hex wrench. Then I just screwed in the levelers. Okay, so now that we have all of our legs cut and the feet levelers drilled and ready to go, it's time to build the apron for the bench. And with 2x4s, they're rounded over from the factory, and I want to remove that round over because I want the 2x4 to be square and flush, sit nice and flush up against the tabletop, the bottom of the tabletop and the bottom of the shelves. However, on the table apron itself that goes around the bottom where your knees and your legs might hit, I'm going to leave that round over, but everywhere else I'm going to remove it. The table aprons are made from standard 2x4s from the local hardware store, though I did spring for the better grade so I could get straight ones. This is simply a process of measure, mark, and cut on the miter saw. And repeat. Removing the round over is a double operation on the table saw. The simplest way I have found is to remove 1/8 inch from each side. Run each board through the table saw, flip, and then do the process again. You could also do this on a jointer or a planer, if you have one. Or you could completely skip this step. I moved the boards over to my assembly table and started the process of laying everything out. Everything is connected together using 3-inch wood screws. In this case, I am using a Torx style head as they are much less prone to run out as compared to slotted or Phillips style. This is optional, but I decided to put leg braces on the ends of the bench just to keep everything aligned. Sanding these components is also optional. We're not making fine furniture here, but I did want to remove any roughness and burrs so the paint will look better and so that it will be comfortable when my legs rub up against it. I chose a gray paint from Sherwin-Williams called Light French Gray. It seems like a nice contrast from the white melamine. I'll just use a small paint roller to apply it. After pouring the paint, I always use the roller to sop up any paint running down the side of the can. Okay, so some of you are frantically typing in the comments right now, and what you're saying is, oh my gosh, you have an HVLP sprayer, we've seen it in all your videos, why aren't you going to spray this? Well, here's the reason why. The reason why is something of this size and of this intricacy, and what I mean by that, it's not just a big flat wall or a big flat area, it's all these little cut-ins and things like that. By the time I set up the paint sprayer and set up a big barrier around all of this, because remember, paint spraying is very messy. The spray and the overspray goes everywhere, so you have to put some kind of curtain up and all of that. By the time I do all of that and get ready to paint, I could be finished with a roller. So that's why I'm going to use the roller, and I'm just going to knock this out real fast. Some people think that painting with a roller causes an inferior job, and that's just not true. If you use a high quality roller and a high quality paint, you can get very good results. Good quality paint has a self-leveling agent that will level the paint and remove roller and brush marks as it dries. However, if you buy the cheapest paint and the cheapest rollers, expect cheap results. With the main table finished, I went to work on the side table. This is mostly an effort of repeating the main table, sans 2 leg posts. I'll have a set of plans, including the SketchUp file for this in the video description. With those plans, you can put this side table on the left or the right side, or you can completely omit it. And of course, we need a little more sanding and a couple coats of paint. Since David was in the building today, he helped me move the workbench bases to the electronics room. This was a big help. Moving the bench down the narrow halls and around the corners requires a little juggling and tilting the bench on its side, but we made it. The side table was quite a bit easier to move. To attach the side table to the main table, I used 3-inch pocket hole screws. Again, we're not building fine furniture here, we're just building a workbench. Though, I have seen pocket hole screws appearing on some expensive furniture lately, and I do not like the trend. Pocket hole screws will be more than strong enough for this build, but you can certainly use something stronger if you choose. Okay, so the melamine comes from the factory with a bare edge, and they make something called edge banding that you can use. It just irons on, it's like got a sticky glue on the back of it and it just irons on. I never think that turns out very well. It never lines up right, and there's always a little gap you can see, and then it winds up peeling off years down the road or months down the road. So there's some ways to get around that, and one of them is, for example, you could just put on, I've got this just some strips of walnut that I have left over from another project. We could put those on the edge, and that would make it look really nice. But this is not fine furniture. It's just a workbench for the studio and for doing electronics on. It's probably going to get beat up over the years, and so it's not fine furniture. I'm not going to do that. What I am going to do is use T-molding. And I have an absolute ton of T-molding from arcade projects, and so I'm just going to use the router and I'm going to cut a 1/16 inch slot down the side of it, and we're gonna slap on some T-molding, and it's gonna look awesome. It's gonna be really durable, it'll last a long time, and I don't have to worry about it. The other thing that I'm going to do is the far corner of this is still squared and boxed off. Just, you know, it's a sheet of plywood that we cut down, and if I round that over, it will make it a lot easier to put the T-molding on because I won't have to join two edges. And the actually real reason is every time I walk into the room, I don't want to bang my hip into that really sharp corner. And so we'll start by cutting off the corner, we'll round it over. I'm just going to use a paint can. And then we'll put on the T-molding.
I get a lot of comments about using fancy tools. Funny enough, I have a fancy tool to make circles and I never use it. I just find something round and trace around it. I'm using a jigsaw blade that cuts on the downstroke. This will prevent chipping the melamine. This type of blade does have a tendency to kick back though, so keeping downward pressure on the jigsaw is a good idea. Using a trim router with a 1/16 inch slot cutter, I created a slot for the T-molding to go into. To attach the tabletop to the base, I'm just going to use pocket hole screws again, since there are no worries about grain movement with particle board. If the tops were real wood, I would have used a slotted bracket to account for the wood expansion and contraction. I placed pocket holes about every 16 inches. Of course, it's critical to use the right length screw so that the screws do not go all the way through the tabletop. It's T-molding time. You guys know how much I love T-molding. I started by cutting the T-molding on a 45-degree angle. This is so that we can start where the main table and side table join. By making 45s, this will create a very clean seam where the two sections of T-molding meet up. I find that using a rubber mallet really helps get the T-molding started without a lot of work. If you're a premium member, I have an entire video on T-molding tips and tricks you can watch. Those 45 makes this joint go together like magic. Sometimes I find a wood block helpful for when the mallet won't get into tight places. Now it's time to make the test equipment shelves. I started by making the two side panels out of some leftover melamine from the tabletops. If you don't have any leftovers, some 3/4 inch plywood would work great here.
Okay, so earlier in the video, we talked about how we were going to remove the rounded edges from the aprons that go on the table. And for the shelves, we're also going to remove the rounded edges, but we're going to remove it from both sides. And the reason we didn't remove it from the bottom side was because we thought, hey, you know, you might be putting your legs into the table, might be banging into it. The rounded edges actually would be sort of a nice thing to have. So we left the bottom ones. On these, though, we're going to cut it off at the tops. And so you can kind of see what that difference looks like. It makes it really kind of square and nice. And so these will make really good shelf braces.
These types of operations are when I really wish I had an outfeed table. That's a project I really need to get around to doing. Now, since we're taking the roundover off on both sides, our 2x4s will be reduced from about 3.5 inches wide down to about 3.25 inches wide. Yep, 2x4s aren't actually 2 inches by 4 inches. You can see the results speak for itself though. Super nice square boards. Again, the shelves are built exactly like the table aprons, just some 3-inch screws. I did place some center braces on the shelves though, not for support, but just to make sure that the long span stayed aligned during the assembly process. 2x4s are notoriously crooked, so I find that using clamps and a speed square make alignment and final fit much easier. Okay, so I get asked in the comments all the time what these little painter's pucks are called. They go by many names, but the ones I have are called bench dogs, and I'll put a link below. Rockler also sells some called bench cookies. Either way, they're a lifesaver for finishing work, and I can't recommend them enough. Pound not sponsored. We'll be using the same pocket hole attachment process for the shelf tops. Since the front of the shelf sides are exposed particle board, we'll also need to route those out and install T-molding. If you were using plywood here, I would still use T-molding to hide the edges. I attached the side panels to the shelves with 4 screws while keeping it secured and aligned with some clamps. Of course, taking proper care to select the right length of screw. This will be much cleaner looking than screws from the outside.
Okay, so here's a little pro tip. When you have multiple shelves or something like that that you're trying to install, a lot of people have the tendency to measure, which is of course a good thing. Measure and then mark a line with the pencil and then hold the shelf in place while you put the screws. Now, there's a problem with that, and that is you're never going to get it aligned correctly, and it's super hard. Like, you got to have 2 people to hold it, because you have to have one person on this end, one person on that end. There's a simpler way. And so what we did is the distance between this shelf and this shelf is 12 3/4 inches. And so we cut blocks of scrap lumber. This is just some scrap 1/2-inch MDF that I had laying around. And we'll put those there. We'll put 2 more on the other side. And then the other shelf we'll just simply lay on top. And then nobody has to hold it. We don't have to measure. It'll just line up and it'll be perfect. Shoot some screws in and we're done. So that's what we're going to do.
These types of techniques are really good to know when you work alone a lot. You have to learn to work smarter, not harder. And many times I can't afford to wait for someone to come help me. Once you finish, you just slide the spacers out and toss them back on the scrap pile. Speaking of working alone, working with pine has one nice advantage. It doesn't weigh much. That makes it easy for me to move by myself. I need to drill holes from the bottom of the tabletop to attach the equipment shelves. To make sure the holes are in the right place, I just created a template using masking tape. That way, I won't make any mistakes and there are no pencil lines to remove later. With the templates in place, I just moved the shelves back out of the way and drilled the holes. Then, I just put the shelves back into position, removed the masking tape, and ran the screws into place from the underside of the bench. As with the tabletop, I rounded the corners of the shelves and covered the exposed areas with T-molding, and then attached them with pocket hole screws. I added a 10-socket power strip to the front of the middle shelf to power all of my test equipment and any projects that I'm working on. I then drilled some 2-inch holes into the tabletop and shelves and added some plastic grommets so we can cleanly route power, network, and HDMI under the table. I added a project mat on the tabletop for a clean work surface. Added my oscilloscope and benchtop power supply to the shelf, and then an electronics microscope and monitor to the left side of the bench. Of course, we also need a soldering station, solder sucker, and a set of helping hands. And no electronic station would be complete without a comfy lab stool to sit on. Ah yes, I am a happy guy.
All right, well, welcome to the new electronic station and room at the Geek Pub. I am so excited that you're following along with us on this journey. Before we end the video, I just want to take a quick second and explain a couple of things that you guys might be frantically typing questions in the comments. And the big one probably is, why build this instead of just, buy it off of Amazon? Well, you can buy these off of Amazon, no doubt, for probably about the same price or even less than I spent on building this. You can buy an electronic station off of Amazon for about $250. And it's horrible. You would not want it. I wouldn't put anything that I cared about on it. I mean, the tops are like cardboard thin, that's made out of this rickety sheet metal. It's not stable. It's horrible. Trust me when I say you don't want those. Now look, they make some really nice electronic stations. Like Uline sells some. There's some other distributors out there that sell some really nice ones. If you want to spend $2,000, $3,000, $4,000, you can definitely buy a really nice electronic station. Now, if I wanted one this size and I wanted to buy it from Uline, it'd cost me about $8,000 because I'd have to buy 2 of them and bolt them together, and that's just a no-go for me. I needed a lot more space, and I didn't have $8,000 to spend. So, so I built this entire electronic station for a little less than $300, and that's with today's ridiculous lumber prices. And so I'm thrilled with this. And you know, look, again, it's not fine furniture, as I mentioned, you know, a couple of times. It is just built out of pine and, you know, particle board coated with melamine and some T-molding. But, you know, I mean, you could build it certainly much nicer if you wanted to use oak or poplar or, you know, any other, you know, lumber that you wanted that, you know, was a little bit higher quality. You know, you could probably for $500 or $600 build the same station nicer if that's what you wanted to do. So there's definitely ways to do that, and it's a far cry from $4,000. So that's number one. The second thing is I kind of wanted to point out is I built this station specifically for my workflow. So I have, you know, inevitably I'm working on a YouTube video or an article about something for the Geek Pub. Especially if I'm repairing something, I almost always find out I don't have a component I need to do the repair. So I have plenty of places up top to store projects that are not finished while I'm waiting on a part to come in. I can move on to something else and keep working. The other thing I did is I set this up as a kind of a YouTube workflow, which not everybody might do, but I have a new addition, the electronics microscope, and I'll be able to see what I'm working on this monitor. And you know, in the past I had to dick with a camera and try to get it, you know, set up on top of whatever I'm working on and focus and the macro lens working, and it's always a huge pain in the butt. But now I don't have to do that anymore. I've got a dedicated electronics microscope that's got a monitor for me, but also over here I have a Mac Mini with a Blackmagic Thunderbolt capture device set up, and so anything that I'm working on the microscope, I can also simultaneously record, which is going to be beautiful and make it so much easier for me to make my videos. So you might not need, you know, a setup like that if you're building the electronic station for you. I do have a link in the description for the plans if you want to build this yourself, and it has all kinds of options. So you can have the side table on the left, you can have it on the right. You can not have a side table at all. You can have 1 shelf or 2 shelves. It's however you want to build it. And so those plans are available in the description if you want to build your own station. Well, I think that about wraps it up for today. If you're not subscribed, please do, and I'll see you in the next video.